Action. Alright, so today we're going to talk about deep water formation, both at present and also how it took place during the Cretaceous, age of the dinosaurs, and how it takes place in the Mediterranean present day. And we're going to learn a little bit about why our oceans are so freaking cold. So we've got a couple ingredients here. We have water, salt, we have some ice as well for fun and games. And we have a bit of food dye as well to sort of follow the water around a little bit. So the first part of understanding deep water formation and how the sort of deep water circulates is understanding how the air circulates. So our atmosphere, both the northern and southern hemisphere, are divided roughly up into 3 different cells of convection. We have the Hadley cell in the tropical regions, where you have generally water, you have rising air near the equator in what's known as the intertropical convergence zone. This rising air is transporting quite a bit of moisture, causing condensation and cloud formation and heavy rainfall, causing these equatorial regions to be quite wet. This is the quintessential tropical rainforest, but also I typically see these big sort of high towering poofy clouds in the tropical regions. This air goes in the upper atmosphere, gets deflected by coils, eventually sinks at about 30 degrees south and 30 degrees north, not perfectly, and as it descends, its relative humidity decreases. The moisture in this air is fairly low to begin with, but it gets drier. And as it gets close to the surface, it heats up and will actually evaporate water from the surface ocean, and typically making the surface ocean hit a little bit, removing water from these sort of subtropical regions. And as symbolized by, I thought I had a little beaker in here that I was removing water with, but let's see if we can redo this. Oh, here we go. Here it is. So we're going to do a little bit of that, create a little evaporation. The way we're going to do this is removing a bit of this water from the subtropical ocean. Water, don't worry, it'll come back. Putting it in here to evaporate it, to give it a little evaporation, or a little kettle, which is plugged in. And we're going to leave the lid open because that'll allow the heat to escape more quickly. Actually, we're going to do is let it get really hot and then make sure this thing's actually on. Yes, it's on, heating. We'll get back to what happens to that later. We'll just equalize the water a little bit here. In fact, if we're really getting excited, we can remove a little bit more water from this system here and heat it up a little more, because the more water that we do this to, the more dramatic this effect will appear to be. There we go. So this dry air, some of this dry air that's descending at 30 degrees north and south, the so-called subtropical high, returns to the equator and picks up more moisture as it flows across the ocean. And then in the rising air near the heated intertropical convergence zone will rise to form more storms. Some of this dry air, however, flows poleward, and if it's flowing across any sort of water source, whether it be a fairly moist forest or ocean, it's also going to pick up moisture. Meanwhile, at the poles, this is an area that's experiencing net radiative loss, so it's losing heat to space, and this leads to sinking air masses both in the polar oceans, North Polar Oceans, and on the Antarctica, the southern polar landmass. The sinking air is quite dry, so it will also float, and it will also descend. And the upshot of this is that in the present-day world, you get huge amounts of sea ice forming in both the northern and southern polar regions. Now, what we have to simulate sea ice formation, we don't have ultra-cold conditions in this room. That would be uncomfortable. However, you can go down to any supermarket in California and buy dry ice. So we're going to do a little bit of dry ice, but create some sea ice using dry ice by expose some of this polar ocean to cold air. Now we're going to do this in several different forms. We're going to try both. We're going to try several different versions of this because inevitably this experiment goes a little funky every time I do it. So. And if you're watching from home, you're probably also seeing some really cool drifting clouds right now, which is awesome. So we're going to do two things. We're going to place some of this dry ice just on top of this beaker. Ooh, that worked really fast. Nice. And I'm going to use another one of these dishes to create some sea ice just in the ocean, hoping that this does not tip over. Oh, this works exceptionally well. There we go. So now we're going to let this whole system settle for a little bit. We're going to create also some Antarctic polar sea ice as well, just for the excitement of it. Oh, this system's working better than I actually imagined. The little bit of wedging of these trays actually makes it. And yes, this is a bad way to do this, but it works. Generally speaking, you don't want to touch this stuff with your hands, but if you touch it for a split second, you probably won't get horrible frostbite. It takes a little longer to do that, so don't ever do what I'm doing, but I assure you I'm not actually hurting myself by doing this. Alright, so now we're going to take a look, see what happens when we pour rainfall on the oceans in our tropical and, upper mid-latitude oceans, where we also get quite a bit of rainfall at this polar front. Oh yeah, when this polar cell air meets the mid-latitude air, this subtropical air flowing across the ocean, the moisture also gets pushed up, and you get these frontal systems that give quite a bit of rain. We call this sort of mid-latitude circulation the Ferrel cell, that you've probably seen talked about in your class. Let's see, is this still going? This keeps evaporating. We're going to let this go. So yeah, I think now we're going to see what happens when we add a little bit of this rainwater to the surface of the ocean. We're going to do this very, very carefully to try to simulate the phenomena as accurately as possible. Watch very carefully. We're going to lower this down. There we go. So your tropical ocean has quite a bit of fresh water at the surface, and usually that warm, fresh water will float just like this layer of dark green water is floating in a tropical ocean. And in the sort of upper mid-latitudes, you'll also see a bit of a layer of fresh water, though it will be a little bit colder and a bit more variable. As the further away from the equator you get, the more seasonal things become, all other factors equal. So what return for episode 2, we're going to now look at what happens when you get high rates of evaporation and what happens when you get sea ice formation. And so get a good look at the setup, and when we get to part 2 of this, we'll take a look. That's good. Okay. I think that went not too horrible.